Hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 11th, 2025. We're looking at an ICLR conference paper from about 3.5 months ago, January 22nd, 2025, titled Unlocking the Power of Function Vectors for Characterizing and Mitigating Catastrophic Forgetting in Continual Instruction Tuning. This paper tackles catastrophic forgetting, or CF. That's when large language models, or LLMs, lose old skills during continual instruction tuning as they learn new tasks. The core idea involves using function vectors, or FVs. These are compact internal representations of tasks, helping to trace and reduce this forgetting. Alright, so this table really lays out the problem we've been discussing. It shows several large language models, like Llama and Mistral, tested on different tasks. We see their zero-shot performance in general tasks. That's how well they perform on tasks they haven't been specifically trained on. And also their in-context performance, which measures their ability to learn from examples given right in the prompt. Those numbers in red, they vividly show the drop in these abilities after further training, highlighting that this forgetting really depends on the specific model and tasks involved. Okay, so building on those observed performance drops, this next figure provides a really clear visual. We're looking at heat maps. These are basically charts where colors represent data values, showing performance changes for Llama large language models during continual learning. That's when they learn a sequence of different tasks. The heat maps track how well the models do on previously trained tasks, general tasks, and in-context tasks. What really stands out is that learning generation tasks, where the model creates new text, generally causes more forgetting than learning classification tasks, where it just assigns a category. And this effect, again, varies with the specific model, reinforcing how complex this catastrophic forgetting can be. Alright, so these next charts really visualize the behavior of these function vectors during tuning. We see bar charts showing function vectors' similarity to their initial state, M0. Then, line graphs track model performance. That's its ability to do tasks with 0 or a few examples, measured by Rouge L, a metric for text generation quality. Across different tasks and later tuning stages, M1 to M5, a clear pattern emerges. As function vector similarity drops, so does performance. This visual evidence strongly suggests function vectors are reliable indicators of catastrophic forgetting. Okay, so if function vectors are good indicators, can we use them to fix the forgetting? These next line graphs explore exactly that. We're looking at performance, measured by Rouge L. That's a score for how closely the model's generated text matches a reference on tasks like HelloSwag and object count. The different lines show what happens when the researchers intervene by, for example, adding back the original task's function vector, called the source function vector. And indeed, these interventions, like adding the source function vector or subtracting a biased target function vector, often improve performance, showing they can mitigate catastrophic forgetting. So, if function vector interventions can help, what about a more proactive training approach? Well, these charts demonstrate the effectiveness of a new method called function vector guided training, or FVG training. This approach adds special mathematical adjustments, known as regularization terms, to the learning process. These adjustments aim to keep the function vectors consistent and ensure the model's internal task understanding, guided by these function vectors, doesn't drift. Looking at tasks like Common Sense QA and HelloSwag, the yellow bars, showing function vector similarity with FVG training, are consistently higher. And as a result, the orange lines, which track task performance, also stay much more stable and higher, indicating that this FVG training really helps mitigate that forgetting. Building on how function vector guided training works, this table then details its actual impact. We're looking at performance across various large language models like Llama and Mistral on different benchmarks, which are standard tests for AI. The table tracks general performance, or GP, that's the model's skill on broad tasks, in-context performance, or IP, its ability to learn from a few examples in the input, and forward performance, or FP, basically its plasticity, or how well it learns new things. The numbers clearly show that adding this function vector guided training significantly boosts general performance and in-context performance, meaning less forgetting, without really hurting that crucial forward performance. So it's clear that this function vector guided training really makes a difference. In essence, this research highlights that function vectors are crucial for understanding why large language models forget, identifying the main problem as biases in how tasks are activated internally. And by stabilizing these function vectors, the proposed training method effectively combats this forgetting. This is a really promising step for making AI better at learning continuously. Thanks for tuning in to the AI Research Roundup. I'm Alex, and I'll see you next time.